Dear children, hearty welcome to today's module. Last class, we were discussing about viscosity, coefficient of viscosity, factors affecting viscosity, temperature dependence with viscosity. Today, in this module, we are discussing the determination of viscosity by Viscometer method using Poiseuille's equation. Firstly, we will see what is Poiseuille's equation. The Poiseuille's equation is used to find out the coefficient of viscosity having laminar flow through a tube. The equation is eta is equal to pi p r power 4 t divided by 8VL. Eta is equal to pi p r power 4 t divided by 8VL. This is the equation which is used to find out the coefficient of viscosity. In order to find out the coefficient of viscosity using Poiseuille's equation, we should know the value of pressure, radius of the tube, time of flow of the liquid, V is the volume of the liquid and L is the length of the tube. Okay, once again the equation is eta is equal to pi p r power 4 t divided by 8VL. This is the Poiseuille's equation where V is the volume of the liquid flowing out of the tube, T is the time taken for the liquid to flow, R is the radius of the tube, L is the length of the tube and P is the driving pressure needed for uniform rate of flow of volume V of the liquid. And this equation is called Poiseuille's equation or Poiseuille's formula. Now, let us see the application of Poiseuille's equation. We have two applications for Poiseuille's equation. First is the determination of viscosity by Oswald Viscometer method and second application is comparing the viscosities of two liquids. The application of Poiseuille's equation are determination of the coefficient of viscosity of a liquid by the Oswald Viscometer method. Second application is comparing the viscosity of two liquids. Now, let us see the application one by one. First application, determination of the coefficient of viscosity of a liquid by the Oswald Viscometer method. In order to understand the Oswald Viscometer, we have a figure of Oswald Viscometer here. The Oswald Viscometer is a U-tube where in both the arms we have bulbs. A is a small bulb. At the end we have a capillary tube B and at the end of this capillary tube B we have a wider portion which involves a wider big bulb C. This is the apparatus and in the Oswald Viscometer a fixed volume of water is introducing into the tube and we are finding out the time of flow or we are noting the time of flow when it is falling out. From the Poiseuille's equation, we are finding out the coefficient of viscosity. And in this experiment, that is the Oswald Viscometer experiment, there is a driving pressure. That driving pressure we can calculate is HdG. How this HdG is come is, we know that pressure is nothing but force divided by area. Force divided by area is the pressure. We know that force is nothing but mass into acceleration due to gravity. Mass into acceleration due to gravity. And we know that density is equal to mass divided by volume. Therefore, mass is equal to density into volume. Then here, this volume is nothing but A into H. That is area into height. That is volume. Area into height is the volume. Then if we substitute all these values here in this equation, that is P is equal to F. F means D into A into H into G divided by A. And this A is getting cancelled. Then P is equal to HdG. That is what the HdG comes. Therefore, in this experiment, the driving pressure is HdG. Pressure is force divided by area. Then force is mass into acceleration due to gravity. Density is mass by volume. Therefore, mass is equal to density into volume. We know that volume is nothing but area into height. When we substitute that here, mass is equal to density into area into height. When we substitute all these values in the equation, P is equal to F by A, P is equal to D into A into H into G divided by A, and the area A and this area is getting cancelled. Therefore, we get the value of P is equal to HdG, where H is the length of the liquid, D is the density, and G is the acceleration due to gravity. When we substitute this HdG in a Poiseuille's equation, we know that the Poiseuille's equation is nothing but pi r power 4 t divided by 8VL, pi p r power 4 or pi r power 4 t into p divided by 8VL. Instead of P, we are substituting this HdG. Therefore, the equation, the Poiseuille's equation becomes pi r power 4 T HdG divided by 8VL. Okay, this is the equation to find out the coefficient of viscosity by Poiseuille's equation. Now, suppose if we have equal volumes of two liquids, we have equal volumes of two liquids 1 and 2, and the densities are D1 and D2, and the coefficient of viscosities are eta 1 and eta 2. We have two liquids 1 and 2, and the densities are D1 and D2, and the coefficient of viscosities are eta 1 and eta 2. And if we allowed the liquids to flow in the same tube under the identical conditions of same temperature and pressure, then we have the time of flow of the liquid as T1 and T2 respectively for the first liquid and the second liquid. Then we can find out the coefficient of viscosities as, that is, eta 1 is equal to pi HdG. This density will be varying. Then r power 4, this time of flow will be varying. Then 8VL, that is for the first liquid, and for the second liquid eta 2 is equal to pi H D2. The density of the second liquid is D2. Then G r power 4, the time of flow of the second liquid is T2. Then 8VL. When we find out the ratio of eta 1 and eta 2, we get the value as eta 1 by eta 2 is equal to this pi, and this pi will get cancelled, h and h will get cancelled. Then we have d1, this g and g will get cancelled, r power 4 and this r power 4 will get cancelled. Then we have T1 here and T2 here. Therefore, T1 divided by here we have D2 is there, then D2 T2. So this is the equation to find out the coefficient of viscosity of one liquid is given to find out the coefficient of viscosity of the another liquid eta 1. Okay. Till now we were discussing about how we can determine the coefficient of viscosity. Now we are going to see or comparing the coefficient of viscosities of two liquids using Oswald Viscometer method. So before we perform the experiment, we will wash the viscometer using chromic acid and then with water. Then we will dry the Oswald viscometer. Then we will introduce a definite volume of water through here and introduce through this bulb. Then some more here we will fill the water. Then after filling the water, we will allow to fall out the water. So using a rubber tube, we will suck the water up to here, some more than the X value, or up to here we will suck using a rubber tube here in D. Then we will allow to fall out the water till Y. Till Y we will allow to fall out the water, and we will note the time of flow of the water, that is T2. Okay. So first we will introduce the water through the bulb C here. Through this end we will allow to introduce the water. Then we will suck the water up to X, little more than X, using a rubber tube. Then we will allow to fall out the water till Y. Then we will note the time of flow of the water. Then that will be the T2. Then using the same procedure we will use for our experimental liquid. So if we want to find out the coefficient of viscosity of any other solvents or any other liquids like glycerol or ethyl benzene or anything, that will be our experimental liquid, and the same procedure we will follow, and using the same procedure we will repeat the experiment, and the same volume of the experimental liquid what we have taken as the water. So what if we have taken 20 ml of water, the same amount of 20 ml of the experimental liquid we are taking through the tube C, through the bulb C, introduced through the bulb C, and we will allow to suck that using a rubber tube up to here in X. Then we will allow to fall out the liquid up to X. That time we will note the time of flow, and by using the equation, that is eta 1 by eta 2 is equal to d1 T1 divided by d2 T2, we will find out the coefficient of viscosity of the experimental liquid. Now we know the coefficient of viscosity of our water and the density of water and the time of flow of water, and we know the density of the experimental liquid, and we know the time of flow of the experimental liquid. So using all these values we can find out the coefficient of viscosity of our experimental liquid. This is about the determination of coefficient of viscosity, or the comparison of coefficient of viscosity of two liquids. Okay, I hope you understood the applications of Poiseuille's equation. Till now we were discussing what is the Poiseuille's equation, that is eta is equal to pi p r power 4 t divided by 8 VL, where p is the dragging pressure, r is the radius of the tube, and t is the time of flow, and v is the volume of the liquid, and L is the length of the tube. And here we discussed about the determination of the coefficient of viscosity of the liquid. To determine the coefficient of viscosity, we are using Oswald viscometer, and this Oswald viscometer is having a U-tube model, and where in the two arms we have a bulb, and in the bulb A is attached to a capillary tube B, and which is attached to the wider portion C, where we have a big bulb. And to determine the coefficient of viscosity, we are fixed volume of water is introduced into the bulb. Then we are allowing it to fall out, and the time of flow is noted. And using the equation eta is equal to pi HDG r power 4 T divided by 8 VL, we can find out the coefficient of viscosity of the liquid. And the second application is the comparison of coefficient of viscosities of two liquids, where we introduce, first we will introduce water, a fixed volume of water through the bulb. Then we will suck the water up to X using a rubber tube. Then we will allow to fall out the water up to here in Y. Then we will note the time of flow. After this, we will wash the viscometer and dry. Then we'll use the another experimental liquid using the same volume of the liquid introduced into the bulb C. Then we will suck using a rubber tube, and here up to X. Then we will allow to fall out the liquid up to Y. Then we will note the value while it is time of flow of the liquid. And using all these values, we will compare the coefficient of viscosities of two liquids, and this we will find out the equation by eta 1 by eta 2 is equal to d1 t1 divided by d2 t2. And eta 1 and eta 2 are the coefficient of viscosities of two liquids, and d1 and d2 are densities of first liquid and second liquid, and t1 and t2 are the time of flow of the first liquid and second liquid. This is about the application of Poiseuille's equation. Now, let us discuss two problems with respect to this Poiseuille's equation and the comparison of viscosities of the liquids. The first problem is, in an experiment using Oswald viscometer, the times of flow for the same volumes of ethanol and water are respectively 175 second and 80 second at 20 degree Celsius. If the viscosity of water at 25 degrees Celsius is 0.01008 Poise, calculate that of ethanol at the same temperature. The density of ethanol at 20 degrees Celsius is 0.790 gram per centimeter cube. The density of water at 20 degrees Celsius is 0.998 gram per centimeter cube. Okay, so this is the problem which is given to us. Here, for the experiment, the Oswald viscometer is used, and we have the two liquids. One is ethanol, and the another one is water, and the same volumes of ethanol and water are used, and the time of flow. Here, the T1, the time of flow of ethanol is 175 seconds, and the time of flow of the water, that is T2, that is 80 seconds at 20 degrees Celsius. If the viscosity of water, that is eta 2 is given, viscosity of water is 0.01008 poise. Okay, then we have to find out, calculate that of ethanol at the same temperature. We have to calculate the viscosity of ethanol at 20 degrees Celsius. That is to find out the eta 1. So now we need the value of, they have given the value of density of ethanol. Density of ethanol is D1, that is 0.790 gram per, approximately gram per centimeter cube. Then D2 for water, the density is 0.998 gram per centimeter cube. These are the data given to us. So we have to find out the eta 1, that is the coefficient of viscosity of ethanol. So we have an equation, eta 1 divided by eta 2 is equal to d1 t1 divided by d2 t2. From this equation, we can find out the eta 1. Eta 1 is equal to eta 2 into d1 t1 divided by d2 t2. Okay, now let us substitute each values. We have all the values. Here the eta 1 is equal to, our eta 2 value is 0.0010008 poise into d1. d1 is 0.790 gram per centimeter cube, and T1 is 175 seconds divided by D2, that is 0.998 gram per centimeter cube. Then T2 is 80 seconds. 80 seconds. So when we calculate all these things, we will get the final value as 0.01745 poise. So here we have gram per centimeter cube, and here we have, in the denominator we have gram per centimeter cube. So we can, both will get cancelled. Then here we have second, here also we have second. So they will cancel. Finally we have poise. So the final answer will be in poise. The answer will be eta 1 is equal to 0.1745 poise. This is the answer for the problem. I hope you understood this problem. Here we have the values of time of flow of ethanol and time of flow of water, and we have the coefficient of viscosity of water, density of water, and density of ethanol. We have to calculate the coefficient of viscosity of ethanol. The equation is eta 1 is equal to eta 2 into d1 t1 by d2 t2. So if we substitute all the values which is given to us, we will get the final value as 0.01745 poise. Okay, I hope you understood this problem. Let us move on to the next problem. That is, in an Oswald viscometer experiment, the flow times for the same oleum, ethyl benzene, density 0.867 gram per centimeter cube, and water density 1.0 gram per centimeter cube are respectively 46.2 seconds and 59.2 seconds at 25 degrees Celsius. if the viscosity of water at 25 degrees Celsius is 0.00895, calculate that of ethyl benzene at the same temperature. Here we have two liquids. One is ethyl benzene and the second one is water. And we have to find out the coefficient of viscosity of ethyl benzene. For that, all other values are given. The density of water, density of ethyl benzene, time of flow of ethyl benzene, time of flow of water, and coefficient of viscosity of water also is given. We have to find out the coefficient of viscosity of ethyl benzene. Let us do this problem now. Here, the flow times for the same volume ethyl benzene. So, ethyl benzene and water are taken in same volume, and the density of ethyl benzene, that is D1 is 0.867 gram per centimeter cube, and D2 is, that is water, 1.0 gram per centimeter cube. Then the T1, the time of flow of ethyl benzene is 46.2 seconds, and T2, that is the time of flow of water, 59.2 seconds at 25 degrees Celsius. Then the viscosity of water is given at 25 degrees Celsius, eta 2, that is 0.00895 Poissy. Now we have to find out the eta 1, that is the coefficient of viscosity of ethyl benzene. The same problem like previous one, we have to substitute all the values here in the equation. Eta 1 is equal to eta 2 into D1 T1 divided by D2 T2. So let us substitute all the values. 0.00895 Poissy into D1, that is 0.867 gram per centimeter cube. Then D2 is 1.0 gram per centimeter cube. Then here this T1 is 46.2 seconds, and here this T2 is 59.2 seconds. So when we do this calculation, that is, if we multiply this viscosity, this D1 and this T1, and divided by this T2 and this T2, we will get the value as 0.06056. The answer will be in Poissy, that is, this gram per centimeter cube and this gram per centimeter cube will get cancelled, and this second will get cancelled. Therefore, the answer will be in Poissy. So, this is the second problem. I hope you understood these two problems. These two problems are in the same model, that is, we are comparing the coefficient of viscosities of two liquids. The coefficient of viscosity, density of the two liquids, time of flow of the liquids are given, and we have to find out the coefficient of viscosity of the second liquid using the equation eta 1 is equal to eta 2 D1 T1 divided by D2 T2. Okay, so this is about the Poiseuille's equation and the application of Poiseuille's equation. So Poiseuille's equation, let us rewind once again. The Poiseuille's equation is eta is equal to pi p r power 4 T by 8 VL, where P is the pressure, dragging pressure, R is the radius of the tube, T is the time of flow, and V is the volume of the tube, L is the length of the tube. And here to find out the pressure, we use the equation P is equal to F by A, where F is equal to mass into acceleration due to gravity, and density is mass by volume. Finally, we get mass as d into a into h. Therefore, if we substitute all this in the place of F here, d into a into h into g divided by a, we will get P is equal to HdG. And here we have an Oswald viscometer. Here we have a big bulb and the liquid is introduced through this end, and we will suck using a rubber tube up to here in X. Then we will allow the liquid to fall out and the time of flow is noted. Then the second experimental liquid also, after drying the viscometer, we are pouring into the experimental liquid through this end, and we will suck the liquid up to here, little more than the point X, and we will allow to fall out the liquid up to Y. Then we will note the flow of the liquid, time of flow of the liquid, and we will compare the coefficient of viscosities of the two liquids, and finally we will get we can find out the coefficient of viscosities of the second liquid using the coefficient of viscosity of the first liquid, and densities and time of flow of the first liquid and the second liquids. So this is about the Poiseuille's equation and applications of Poiseuille's equation. Thank you.